guess maybe I should start with asking, did anybody have any questions with regard to the homework, to building that calculator? Did anything strike anybody as above and beyond or unusual? Yeah.
I tried to put in a string, like string from character array, but
Okay.
like I can't seem to like break the pieces down correctly.
Okay.
Is there any way to do that?
So you're talking about walking through that string character by character, and
Yeah.
I think I did see your email. I figured we just talk, but yours is a pretty good example for what I was going to actually cover. So the scenario you were running into is some people were taking the operator. They would try to seek out the operator in the string, and then they'd split the string. And that left them with the numbers on both sides. Your approach, which is actually, it's a little more sophisticated, but it gives you more flexibility, was you wanted to go character by character within the string. You wanted to identify what parts of the string are the number, what parts of the string are the operator, and then be able to execute that string pattern into a mathematical equation.
Yeah.
And your problem was that you were going, like 200 plus 500, you would get 2, which you figured out was a 2, but then you'd get 2 zeros, and you were having trouble trying to determine logically whether or not those were part of the same number, right? Okay. So that's actually a pretty good example of what we're going to kind of go through. Today, what I'm going to talk about in particular are lists, arrays in general. I'm going to also talk about the stacks and queues data types that exist within the framework, and actually a stack works well for what the approach you were trying to take, where you can take in a character at a time, put it in a stack, and then unpack it back. And as you unpack it, you basically look at, is this a number? Yes. Is this a number? Yes. Is this a number? Yes. Is this a number? No. Okay. Those 3 characters represent a number.
Okay.
And then you kind of work that way with it. And then you can say, okay, this isn't a number, this is an operator. Put that in the list and kind of work it that way. That would be the best solution for what you were trying to do.
Okay, sounds good.
Okay. So we'll go through that actually in the lecture today. Okay. So has anybody ever heard of a linked list? Okay. Anybody ever heard of a stack? All right. And a queue? Okay. All right. So those are pretty common collection structures within most languages. I remember my C class that I took, they asked us to create stacks and queues and linked lists. So they're fun, but they're really complex and can kind of get unwieldy, especially when you start dealing with linked lists and moving items within the list and things like that. Luckily for us, Microsoft took care of writing all of those for us as part of the .NET framework, so you don't have to go in and create your own. Just as a general rule of thumb, this isn't mine, but this is something I read and I thought it was pretty, not profound, but realistic. Microsoft employs a lot of smart people to write stuff. So instead of inventing your own, if you don't find fault in what they do, you're probably better off just using what the team of people wrote in terms of efficiency and performance and what it's able to do. So for myself, I used to be a person that I like to go and reinvent things just because it was fun. And after I read that, I kind of went, okay, I guess I don't have to reinvent every wheel for myself. So if you're that kind of person, that's kind of my recommendation to you. And if you're not, well, then just use these. So all of your different types of collections live underneath the namespace of, actually, I'll just bring it down here, of system.collections. Okay? So inside of this namespace, we have additional namespaces, and we also have classes. And as the framework has evolved, new namespaces have been defined to kind of give specificity to these particular classes and objects. But generally speaking, all of your collection data types, structures that you would need, all live within the system.collections namespace. I'm not going to go through each one of these, but I'm going to kind of highlight a few key ones that will probably be of value to you in the future. There are many in here, and they each have kind of a specific or unique purpose. So I just recommend kind of going back and looking at this because you may find something in here that may be of value to you, again, so you don't have to reinvent the wheel. Start off with array list. And an array list is one of the most simple list types that exist. Now, I say list type because it's a list, not an array. And the difference, two primary differences are An array is it's a structure in the sense that once you define it and you give it a fixed size, that size is fixed. You have, if you wanted to extend the size of an array, you actually have to declare a new array and then transfer all of the elements inside that array to the new one to extend it. So if you declare an array and you say I want a 10 position array, and then you realize that you need more than 10 positions, you actually have to, the mechanics are to go declare a new array of 20 positions and then transfer the first 10 positions or the first 10 items from the old array into the new array. And then you basically let garbage collection pick up that old array and it blows it away. With a list, you can dynamically grow a list. You can add elements to it, take elements out of it, and it will grow and shrink as needed depending on the number of elements in the list. So those generally make more sense to us because a lot of things that we interact with on a daily basis, be it a Word document where we're typing in lines or whatever, we're used to that idea of going and removing lines, deleting rows, taking things out and actually compressing down to be the appropriate size. So an array list serves that purpose and allows that. I know that there is an array list structure inside of Java. The array list in .NET is different than the array list in Java. So the array list in Java implemented what was called generics. The array list in .NET is not that thing. It is actually just a regular bucket that stores objects. So if I say array list dot add, and most of your lists have an add or remove, a contains, an index of method so that you can add items to those lists. So if you do an add, what it's looking for is an object. So if we remember, all classes within the framework inherit from objects. So basically this array list can hold any kind of object that it wants. Okay. The downside to that is that once you take an object and you put it in here, be it the student object that we worked with last week, or if we create, if we just have strings, those are objects, numbers, integers, floats, booleans, date, time values, those are all inheriting from system.object. So once we put those into this array list, it then abstracts away that data type. So when we go to retrieve, so if I say new string, I'll just put a string in here, apple. So in my first position, position 0 of this array list, I now have a string in there called apple. If I go array list 0, if you notice the IntelliSense says that at position 0 of this array list, it will return an object. And I can clarify it going this way. I'm sorry. Yeah, I'm sorry. This is the only way to access it. So we can say object val1 equals array list. And that will work. If I were to say make val1 a string, because it is a string, it will give me a casting exception saying that it cannot implicitly convert an object to a string. Therefore, the only options that you have is to cast that item. So, yeah.
I was just thinking, in like Java, you had to use like, whatever, like the less than.
The angle brackets?
Yeah, and you had to put the data
Right.
type or something like that.
Right.
Or
So
you
that,
had to use it.
yeah, so that is called a generic.
Okay.
So,
Is that what you meant? Okay, that's what you meant by that.
yes.
I was wondering.
So there are structures in here, and I'll get to those as we talk through it. And what a generic does is allows you to specify a single data type that collection is kind of bound to.
So like you can only have strings or numbers.
Exactly. Yep. So the array list in .NET is just this open bucket that says I'll take any object, which means I'll basically take anything. But it doesn't track or have this binding to a particular data type, so when you end up putting stuff in there, you are responsible for keeping track of what it is. So it definitely has its good and its bad. This is a particular structure that has existed since the first version of .NET, so obviously better solutions such as generics have come along, and generally speaking, you want to use the newer stuff because it works better. But that's not to say that you couldn't run into a scenario where you would want to use an array list. So, simple enough. Beyond that is a... Actually, I think those live under a different space. Okay. The next class is a hash table. And a hash table is basically a dictionary, if that term makes any sense. It's a key value pair collection. So you have a key that uniquely identifies the object, and then the value is the object itself that you're trying to store. Yeah?
Is like a built-in hash function with the hash table?
Say that one more time.
Is a built-in hash function for the hash tables?
To generate hashes?
Yeah.
No.
Okay.
So, basically, you want to use this for generating dictionaries. So, what I often see the use of this is that if you have so if you're pulling data from a database, for example.
I've created a hash table before, so that's why I asked.
Okay. Yeah. Now there is off of most of your objects. Let's say string. You can use this get hash code, which in theory is supposed to generate a unique integer value for any object.
Okay.
But there are some constraints because obviously you're dealing with integers, so you only have like 32,000 possible combination values.
Right.
But that is one of the means that the framework uses when comparing two objects to determine if they're the same.
Okay.
So it generates somewhat of a hash code or a hash for it, but it's not the same as what you're talking about. It's not as dynamic or as broad as what you're thinking of. So. Mm-hmm. So with the hash table, you basically have a key and a value. And for most people, if you're familiar with any sort of database design or database work, you always end up with a table that has a primary key value. It's normally an integer or a GUID of some sort. And that ends up being your lookup or your index for those rows inside of that database. So people can generally relate to this idea. So you would have a key, which is that primary key, and then you have the value, which is basically the rest of the data in that database row. So if you were to extract data from a database and you were to generate an object, taking those rows and columns of data and mapping those to properties, you would still want to have a fast way of looking up and retrieving those values, those objects. And you probably want to do it by ID. So you can generate a hash table that has the primary key as the key, and then the actual object, the instance of that row object, as the value. So we can say 1, comma, I'm just going to use a string again. And then on a hash table, you would say get me 1. And again, the limitation here is that hash table is going to return an object, not a string, so you have to do the casting. And actually, just for variety, I'm going to show you this is another way you can cast. So basically, it'll take that value and say as string. The difference between this way of casting and the way above is that the as string or as notation basically is only good for when you're casting a variable to a class type. So if you remember from the first week, we talked about classes and structures. If the data type is a class, you can use the as notation because all classes can be equal to null. So when you create an instance of a variable, you can set that equal to null. With a structure, when you declare a variable as a structure, it has a default value that it takes on. If you declare, int age, this value or this variable age has a value. Even though I didn't assign it a value, it automatically has a value. So because it's a structure, it automatically takes on a value and can never be set to null. If I create string name, since string is a class, I can set name equal to null. And I'll show you this just as a comparison. Most of your structures are called non-nullables. So because your structures are non-nullables, you can't set a value. There is a newer thing within the framework. I think it came in version 4, and we'll talk about it later. It's a generic container that allows you to take structures that are non-nullable and make them nullable. So we'll talk about that later. But so if you do this casting as string to this, what's nice is it's kind of a error handling. So if we were to make this statement above and say, take this and cast it as a string with the parentheses, if the variable is not a string value, you'll get a casting exception. So let's say that this isn't a string, that instead I put in here an integer. This line will blow up because 12 is not a string. Correct? I mean, it's not. It's a number. So by doing as string here, it will attempt to cast it to a string, and if it fails or is unable to do so, it will just simply return null. And that's kind of your indicator to say whatever was in there is not a string because it returned null. Alright, and we'll touch on that more, but I'm just trying to give you guys a sense of some of these elements. So, alright. Let's see if there's other ones in here I want to just touch on. Sorted list is kind of like an array list in the sense that or actually I should take that back. It's more like the hash table. In that you have a key value pair, and this automatically sorts based on that key. So you're able to enumerate or go through it an item at a time, but it automatically sorts by that key. A hash table does not sort by the key; it's simply a lookup. So there's a difference there, and so with the sorted list, more or less, you can do a for each, or you can do a for loop on a sorted list, and go through it an item at a time, and it'll automatically sort by that key. An array list will not sort by the key; it will just leave the items in there in whatever order you added them. A hash table does not allow you to loop through each item in there. You have to know the key in order to retrieve the value. So those are some nuances just between those different structures. With stacks, you don't have the add and remove because by design they're made to be added to and removed from. So instead what you end up with is these concepts of push and pop. So you have a push method to push or add an item to the stack and a pop to pull the item off the stack. So if you remember, a stack is a first in, last out. So you push items into the stack and it grows and grows, and then as you pop them off, you're popping them off the top. So you're taking whatever was the last thing put in and you continue pulling them back out. A peek allows you to see the first object in the stack, or I'm sorry, the top object in the stack without popping it. So you basically take the lid off the stack, you peek inside, you see what it is, and then you get to know what that is without removing it from the stack itself. that we can push. And again, this takes an object, so it's kind of just this generic container that takes whatever you want.
Since it's first in, first out, you want to assign values.
Correct. The object that you put in there is the value. So basically, you're adding a value, you're adding an item. Yeah.
So,
If you're like putting like an array and putting it to a stack, or maybe like a string
Alright.
and putting it to a stack, is there a way to like choose how the chunks of the string you're putting into the stack?
Choose the chunks of string that you're
Like
putting.
if you had like 1 through 9 with words, you would put like 1 into the stack and
Yeah.
it becomes a string, a straight string. Is there a way to like stop at certain points and put like a full word into a stack?
I don't think so, but maybe we can go through it once we get into it more. I know you're trying to work on the homework,
Yeah.
so yeah. As we get through the lecture, maybe bring that up again so
Okay.
that I can. I'm having trouble visualizing what you're talking about.
Okay.
So if you have more stuff.
and I was just saying, so now that'll be like the first one. If you got something else on top of the image.
Yes. Yeah. So if we ended up and we push. So if we have those three values, what that ends up looking like is like this, and if you think of it as a list. Okay, the string on the bottom. So then this pop will pop world. This will pop hello. This is coming from the top. And then this will pop string. Okay? Alright, cues. I'm just going to put this, so this is first in, last out. This is last in, last, or well, first in, first out. So with a queue, you have, oh, I just cruised right by it. You have DQ and NQ, or Q, and however you want to say. NQ basically says add the item to the queue. DQ says remove the item from the queue. So if we use the same three strings as above, we say string hello world. So we've queued them up, and then we go this is string hello world. Okay. Alright, let's see. I think that's everything I wanted to cover there, but I may have missed one. Yeah. Just for your information kind of a thing, some other pieces that may be of value to you, if you need to go in and create your own collection for a reason, or you need to create your own dictionary structure for any reason, the framework does try to be a helper to you so that you don't have to code everything by hand. So you do have a collection base and a dictionary base class that you can inherit from, and you can use those when you're creating collections or dictionaries. There also is a series of interfaces that are defined in here. Do you guys know what interfaces are? Okay. Have you guys implemented interfaces before? Have you defined interfaces before? Okay, that's fine. I'm going to get into it because I love them. So, I'm not going to get into it now, but I'll get into it later. But you have a series of different types of interfaces in here. So we also have a specialized namespace, and I'll just kind of cruise through this real quick. And it's, again, another series of different types of collections. So you have a list dictionary, hybrid dictionary, a name value collection, which is basically like a hash table or a hash set, but it's a little more streamlined, and it works strictly with keys, or I'm sorry, with strings. An ordered dictionary, string collection, so it's basically like a string array, string dictionary, and again, these are older structures from early versions of the framework. A lot of the generics have kind of taken over the necessity of a lot of these, but they still have value and some optimizations to them versus using generics, so don't discount them, just they may not necessarily meet the need of what you're trying to accomplish. Under the generic namespace, this is where a lot of the probably more common, more functional collections live. So compare is actually used for implementing a compare between two items. So for dictionaries or searches, you can use a compare. The dictionary here, so in the bracket T notation, is used for kind of denoting that something is a generic or has a generic. So I just want to take 30 seconds and explain generics again, just for anybody that's not that familiar with them. What a generic is or does is it allows you as the programmer to explicitly define and bind a structure to a data type. Okay, so what that means is if we take this dictionary, or actually let's go with a list first, because a list is probably the most obvious. If we go in and we create a list, and we say this is going to be a list of date time, then when I go datetime_list.add, the runtime infers from this bracket notation, date time, and it says this instance of this list can only take in date time values. So if I try to put a string in here, it's going to turn around and tell me, if you look down at the bottom edge where it says error, it says the best overloaded method for system collection generic list date time add is date time, and it has some invalid arguments, because that's basically saying that you're attempting to put something that is not a date time into this function call. Yeah, so under that generics namespace, you have a whole series of special collection types that are only for generics. Now, if we decide later that, oh, well, we really wanted to use strings, the only thing that you have to do is go in here and change this declaration to string, and then change this instantiator or initializer to string, and now everything works. So the compiler and the framework dynamically work around the fact that you have these data types that you're strongly binding to these collections. There's other instances of uses of generics, and that has a lot to do with delegates, and we'll get into delegates later. You can even create certain functions that are generics, so that when you go in and you actually call the function, you're defining in the function call, these are the data types that are going to be passed into this function. And then it's the programmer on the other side defining those, it gives you a greater level of flexibility because you don't have to worry about, or for that matter, in most cases, care about what's being passed in. You're leaving that liberty up to the end user developer, the programmer that's using your code. So as we get into it, I've got an entire class where I talk about generics and go into that in more detail, but for the sake of this, I just want to give you some familiarity around them. Alright, so we put in a type, and it basically becomes like an array. When you declare an array of strings, you say this is a string array, and then you put your strings in there. You can't put date times in there, you can't put integers in there, it only works with strings. Same concept. The beauty of this is that we can go in and add dynamically as many as we want. Now obviously this name doesn't match anymore, so we'll call it a string list now. I can rename this variable. I can do a control I, pull up the accelerator. I can say rename date time list to string list, and then it will go through all my code and find all instances and rename them for me. So that's a nice little Visual Studio's bonus. Okay. Dictionary. Generic, same kind of thing. So in here, we're using two generics. We have to define two generic values. And one is the key type, and one is the value type. So if we go back up and look at the regular hash table, which is the equivalent of that dictionary, when you give it a key, it just takes it in as an object, and the value, it takes it in as an object. Down here, when we're actually defining what our key type is going to be. So in here I'll say this is an int, and this is a string. So now when I say, let me shorthand that. Dot add, it's going to say to me, okay, give me an int as a key and a string as a value. Inversely, because I've strongly typed this, I can now say 1. And if you look at the signature, it says it's going to return me a string. So I don't have to do the casting back and forth and worry about tracking and keeping track of data types. I know that I'm always going to get a key that's an integer, and I'm always going to get a string returned as the result. And the same goes with this up here. So if I say string list position 0, I know that it's returning a string to me. Generic. So you have a list, dictionary above. You have linked lists, which are technically considered doubly linked lists, so you can have this idea of dynamic relationships. You have queues, you have your sorted list, sorted dictionary, same as what we've seen before, stacks, and again, you're just defining for yourself and for the framework the data type.
So using generics pretty much just saves you headaches later.
Yes. Yes. So you're strongly typing everything at design time, so that way you don't run into runtime errors. So yeah, you're saving yourself a lot of headaches by using the generics. So 9 times out of 10, unless it's either by design or something that you're doing, like out of necessity, you almost always, as the developer, want to go the path of using a generic when you can, versus just using the object, because the object will put you and whoever's using your code just in all kinds of what ifs and having to keep track and manage that stuff. So I recommend it. Interfaces also come in handy in some of those cases, and we'll get into that later in the term. So with a string stack, you have a lot of the same conventions. Your push and your pop still exist. It's just now they are, again, strongly typed. do the casting. Okay. So, any questions around that? Hopefully that's pretty straightforward. Okay. So, now that we have all these structures, what can we do with them? So if we go back to what we were talking about and what the homework assignment was to create that calculator, the idea here was for us to create a basic calculator and it takes in typed equations. Alright, so Alright, so what this should do for us, if we refresh, is it'll say basic calculator takes in typed equations. So I'm just going to type in something. It's just going to keep refreshing, asking me for values until I hit Q, and then it'll exit out. Simple enough. So what we want this to do is to take that equation and do something with it. So what we're going to have is the input, which will be the equation. We'll want to parse that equation, determine if the parse is valid, good equation given, do the math as defined, and then output the result to the user. Okay? Probably don't want to clear the output. So, okay. So the first step is to parse the equation. Now, to do this, I'm going to create a new class and we'll call it the math engine. And the math engine will have a constructor. So shorthand for that is CTOR. Double tab. Visual Studios will generate that constructor template for you. Constructors, just like in Java and pretty similar to what you see in C++, is basically a duplication of the class name. This is a void or a null instructor, so it basically doesn't take anything in and it creates an instance. If we want to take in a value, we put it in here as a parameter. And then this becomes an input value, so when we then declare, when we say new, our input equation then becomes that parameter that's passed to new. Okay, see the correlation there? Before this, we'll have a private string input equation. Store the input equation. We'll then want to validate the equation. Now to create a method called parse and validate. And then we will have a calculate method. And perform the calculation. So this is the grunt work of our application. So when we were talking before about how do we take that string and parse it and determine the values, we talked about different mechanisms that we could use. A lot of the scenarios that I saw from the homework was the use of split. You had basically an array of operators. You would take the input equation, you would split on one of those operators, and you would cross your fingers and hope that they only put in two numbers in one operator and that you got back two values, which were your numbers, and then you would figure out what operator they put in, and then you turned around and did the math. Which is fine. I'm not judging anybody on that. Perfectly valid way to approach the problem. If someone were to say, give me what 2 plus 2 plus 2 is, your program would either blow up or give them 4. Right? So, how do we make it so that this application is more flexible and allows us to do something such as 2 plus 2 plus 2? Well, it's a lot more complicated than that, but that's kind of the starting point. So what we need to do is be able to take numbers and those operators out of that string, presumably one character or one number at a time, which goes back to what Chris was trying to do. So, to do that, the approach that I've seen in the past, and I think is still just as valid, is to go about starting with a stack. And I'm going to start with a stack of strings, because what we're bringing into as the input equation is a string. And this will be input EQ stack, I'm going to call it. Okay? And then what I'm then going to do is I'm going to loop through my input equation one character at a time, pulling those values out. So we'll have string, actually we'll say char C in input equation. this should probably be chars. So input EQ stack push C. This basically copies all characters into the stack.
Is for each basically like a that's like basically saying for like for if I stack dot or stack dot count whatever push back onto the stack. Yeah.
Yeah.
That's really nice. Nice.
Yeah. And it only works if you have a collection that's enumerable.
Okay.
Most of them are, but it only works if it's enumerable. So your equivalent here could be input EQ stack dot push. Okay, so that's the get a little bit of for and for each going on at the same time. So all this is doing is it's going to go character by character, one at a time, through that string, copy that character into the stack. I want to do one more thing. I'm going to do a quick validator. If string is not null or white space, input equation. I'm sorry, if it is null or white space, input equation, return false. This method takes in a string and returns a boolean. Basically what it's going to do for me is if input equation is blank, it's going to just say true, it is null or white space, it is nothing, and therefore I'm going to return false from my method saying that this did not parse and is not valid because it's blank. This is nice, this method, because the equivalent to it would be saying input equation equals null or input equation dot length equals 0. So you can type all that or type one method call. All right. I'm actually getting ahead of myself. No, I'm okay. Alright. So what I would like to do is as we go through this character by character, I think, and what you were getting at was how do you make chunks,
Yeah. This is where I
right? So how do you take, if you have 200 plus 200 and go from 200 to 200 to say that this is a number, then the operator, then 200.
It would go 0, 0, 2, even if it's 200. So you pop into
Right.
Yeah.
Yes. All right. So yeah. Let's use a queue instead of a stack then.
Okay, yeah, that makes
Yeah. So the stack works better when you start dealing with things like parentheses because you're kind of like walking back and you can, I won't get into it. A queue will work better. So what we'll do is we'll change this to a queue. And then we will enqueue that. Alright. And then we will then begin by pop values, find numbers. So while input stack or input equation q count is greater than 0, So while there's numbers in the queue, we will examine the value received from the queue. We'll attempt to parse the value into an integer. We'll attempt to match the value to an operator. And then store it into a calculation queue. Okay? So to do that, we'll first have to come up here and create another private variable. Call it the calculation queue. And then we'll have to initialize the calculation queue variable, because this right now is just a variable that's set to nothing. So if we try to access it without initializing it, setting it to an object, it'll return null and we'll get a null reference exception. So we have to actually initialize that to be a new queue. So this will store a number as it's being built, and this is the value being examined. Now, as I'm going through this and explaining it, and I'm kind of reevaluating my code, I'm considering if we've got duplication of work. For the time being, I'm going to leave it for demonstration purposes of how to use a queue and things like that, but technically we could probably do these steps inside of this for each loop. It's kind of what I'm considering. Neither here nor there. So what we'll start off by doing is the value examined will be the input queue pop. Sorry, DQ. And then I'll say int numval. If int.tryParse, the value examined output numval is true, which is basically saying, will this character parse into a integer? If it does, then we'll say a number equals value examined, well, plus equals this once it is a string. Yep. Okay. So if it's a number, we'll store it as a number. If it's not, then we'll go on and do some additional testing. If value examined equals a dot, then I say a number plus equals value examined. So basically we have a decimal value here, so we want to store that decimal. If not, then we'll say if value examined, well, we'll actually say, and I have to declare this, operators contains value examined. So we'll have to define our operators, which we can do up here. So private character array operators. Plus, minus, multiply, divide, so logically, if we get to the point where we hit an operator, the first thing that we need to do is check for a number currently being built and move it to the calculation. What do we call that? Calculation queue. So we'll use that is null or white space, but this time we'll say not. So if it's not null or white space, then we'll enqueue a number. I'm going to use a static property, string.empty, which is the equivalent of that. Kind of your own preference. I tend to use that one, but the other one works just as well. Then we'll say our calculation queue will want to enqueue the value examined, casting it as a string. Alright. Okay. The final step we'll want to do here is we'll want to check if So up to this point, what's happening is we start off with the application. We basically say, give me a value, or give me an equation. We'll have our math engine take in that input equation. we'll want to parse and validate. If it's valid, we'll want to calculate. So we'll do the calculation, and then output the result. With the parse and validate, what this is going to do is it's going to start by going through the queue of characters. It will pull them out of the queue one at a time, try to parse it into a number. If it can, it will then start to build a number. If it comes across a decimal or a dot, it will add it to the number, assuming it's a fraction or a decimal number. If the value examined is an operator, then we'll go through and determine that a number is not empty, that there is something that was being built prior to that operator existing. We'll then queue that number into our new queue for calculating. We'll then clear out the number queue, and then we'll go ahead and add that value examined, the operator, to the calculation queue. Basically building that equation to be calculated. What will happen is we'll loop through all of this, we'll get to the last equation, or the last operator, will then be building that final number, and then if we don't actually store the final A number into the queue, we'll end up with 2 plus 2 plus. So to do that, we have a few things that are going on here. A number doesn't exist outside the scope of this while loop. So I need to move that out here, because we want to be able to capture a number, whatever that is, after the loop is over. So by simply moving it outside the while loop, we now have a number in scope. So then the calculation queue, we will add the final A number. And I'm going to say if not string is null, or white space, a number. So if there's a value to a number, queue it up. Else, return false. Meaning that the equation does not end with a number. So if I were to type in 2 plus 2 plus, that's not a valid equation technically. So we should say that it didn't parse correctly and throw an error. Assuming we make it to the end, we'll say true. Alright, does that make sense? Okay. You guys have been sitting for an hour, so let's go ahead and take a break. Give your brains a breather. And we'll come back in 5 minutes.